What is up, my chem disciples? Today we're going to be covering the three types of chemical equations that you could potentially write for a single one. We're going to start by using the basic one that you should all know, which is a formula equation. So the formula equation is simply the completely balanced equation that shows all the potential reactants that you were given and all the potential products that you could form. So to illustrate this fact, let's use this reaction that we have right here. Between lead 2 nitrate and potassium iodide. So when lead 2 nitrate and potassium iodide react together, you're going to form these two things. So PbNO3 2 plus Ki. Those are going to react to form. Remember that the outsides react with each other, so lead and iodide are going to combine. So you're going to form PbI2 plus. Now potassium and nitrate are going to combine together to form KNO3. The next step would be to simply balance this. Let's start with our nitrates. So on the left side, you have 2 nitrates. On the right side, you only got 1, so you're going to put a 2 in front of KNO3. That increases the amount of potassium that you have on the right side. So now you have 2 potassiums on the right side. You only have 1 on the left, so you're going to put a 2 in front of Ki. This changes the amount of iodides on the left side, so now you have 2 of them. But hey, look, you already have 2 on the right side, so you don't need to change anything. And if you want to double check with lead, you only have 1 on the right side, and you only have 1 on the left side. So this is perfectly balanced. The next step in a formula equation would be to simply add in our states of matter, so basically deciding if something is aqueous or a solid in our chemical reaction. For that, you're going to use the solubility rules. So they're about like 6 or 7. Sometimes they'll throw in an 8th one. But we're going to go over the 3 most important ones. The first one being all nitrates are soluble. So if you see something with an NO3 on it, you automatically put aqueous next to it. No ifs, ands, or buts. So we can already do that to some of these. So if you look right here, we have lead 2 nitrate. Regardless of what's attached to the NO3, you automatically just put aqueous. This is soluble in water. And you can do that to potassium nitrate. This is going to be aqueous. All right, so I've already knocked out 2 of them. Let's go to the next one. Group 1 alkali metals, that's the first column on the periodic table. So if you see anything that has lithium, sodium, potassium, rubidium, you're probably not going to see cesium. You automatically put aqueous. And ammonium ion salts are soluble. So if you have NH4 plus or anything from the first column attached to a nonmetal or anion, automatically put aqueous next to it. So we can already do that with Ki, potassium iodide. Potassium is a group 1 metal, so you're just going to put an AQ right here. Now, the third rule, chlorides, bromides, and iodides, that's the halogens or the group 7A elements. So chloride, bromide, and iodide are right here. Those are all going to be soluble with the exceptions of silver, lead 2, and mercury 2. So if we go to our very last one, we have lead 2 iodide. This would be soluble if iodide was not attached to lead. So that means that this is going to form something called a precipitate or an insoluble substance. It's going to be soluble in water. So this is going to be known as our precipitate, which I'll abbreviate as PPT. Okay, so that's how you would write a formula equation. You all should be very familiar with it. This is not an actual representation for what is going on in the reaction, however. For that, you would use the complete ionic equation. So what the complete ionic equation is all the reactants and products that are strong electrolytes. Strong electrolyte just means soluble in water, or it's a strong acid and base, are going to be represented as ions. So you're going to take every component in the original formula equation that's aqueous or soluble in water, and you're going to split it apart into its respective ions. So let's start with lead 2 nitrate. We have PbNO3. So this one we said is soluble. So when we write in the complete ionic equation, we're going to have Pb2 plus by itself plus NO3 1 minus. So these are the ions that make up lead 2 nitrate. We're not done yet. We still have potassium iodide, which we said was soluble. So this is going to be plus potassium ion with a +1 charge, and iodide ion with a -1. Okay, so let's move on to our products. Now we hit a snag in the road. We have lead 2 iodide. Lead 2 iodide is not a strong electrolyte because it doesn't dissolve in water. That's why we put this solid right here. So this is going to be written as itself. So we're not going to split up lead 2 iodide. So this is going to remain as a precipitate. However, potassium nitrate, we said it was aqueous, so that one will split apart. So it'll make K plus NO3, 1 minus. So all these ions, we're just going to assume they're aqueous. We don't need to write down aqueous 6 separate times. We can tell that they are aqueous because they dissolved in water. Now, this is a pretty good representation for what's going on in the reaction. However, there's a lot of empty space. If you notice, our nitrate and potassium ions aren't really doing anything in the chemical equation. They're kind of just floating around. And for that, we have a term for them. Those are known as spectator ions. So these spectator ions are simply the ones that aren't reacting to form any sort of precipitate or something that is insoluble. So we would label potassium and nitrate as spectator ions. And what this is useful for is for writing the net ionic equation. So what the net ionic equation is, it basically includes only the components that undergo a change, which basically means eliminating out any spectator ions. So we're going to take the complete ionic equation and we're just going to cancel out all the things that are not forming our precipitate, which in this case is lead 2 iodide. You can even think about this algebraically, and you see potassium ion is on the left side, potassium ion is also on the right side, so you can cancel those out, and you can do the same thing with nitrate. There's no lead 2 on the right side, and there's no iodide on the right side, so you can't cancel those out. So when we write the net ionic equation, we're only going to include lead 2 iodide and lead 2 iodide, the combination, the precipitate. So we would have Pb 2 plus I minus yielding lead 2 iodide. And this is the thing that you guys want to get really good at writing, the net ionic equation. This is going to make your life so much easier. Okay, so the steps that you're going to want to take is writing out the formula equation and just noting all the things that are soluble and insoluble. Remember that that insoluble substance will be known as a precipitate. Then you would write the complete ionic equation. You split apart all of the aqueous solutions into their respective ions. Then to write the net ionic equation, you would just eliminate all of the spectator ions from the complete ionic equation. In the case of this one, our spectator ions were potassium and nitrate. All right, let's do another example. We are going to do one for the reaction between ammonium chloride and sodium bicarbonate. Ammonium chloride is NH4Cl. These both have a +1 and -1 charge respectively. And sodium bicarbonate, which is NaHCl3. These both have a +1 charge and -1 charge respectively. Okay, so the reaction between the two, or the formula reaction between the two, is going to yield these things. So it's going to be ammonium chloride plus sodium bicarb. And now remember, the outsides are going to react with each other, so you're going to react ammonium and bicarbonate to form NH4HCl3 plus the insides will not react, so you're going to make sodium chloride NaCl. Everything should just have a coefficient of 1, so you have 1 ammonium on each side, 1 chloride on each side, 1 sodium on each side, and 1 bicarbonate on each side. So this is completely balanced. And now the last thing is to just make sure that we write down our solubilities. So if we look at the rules, we can start eliminating them out already. For rule 2, group 1, alkali metals and ammonium salts are completely soluble. So here we have an ammonium, so that means this is soluble, aqueous. Here we have a group 1 metal, that means this is soluble, no ifs, ands, or buts. And it's the same thing going on the right side. Here you have ammonium, automatically soluble, and here you have sodium, which is a group 1 metal, so it's automatically soluble. Cool. Now we're going to write down the complete ionic equation. If you notice, no precipitate has formed in the actual reaction, so you are going to pretty much split apart everything. So in the complete ionic equation, it's going to be ammonium ion plus chloride ion plus sodium ion, and then plus bicarbonate. Then it's going to be a lot of the same on the right side, so you're going to have ammonium ion plus bicarbonate plus sodium ion, and then plus chloride ion. Now, if you notice, no precipitate has formed, and the left side of the equation looks exactly the same as the right side of the equation. So you could actually cancel out all of these ions. So ammoniums get canceled out, chlorides get canceled out, sodiums get canceled out, and bicarbonate gets canceled out. So what that means for the net ionic equation is there is no net ionic equation. No reaction actually occurs. All of these are considered as spectator ions. So when everything in your mixture is soluble and no precipitate or weak electrolyte ends up forming, you don't have a net ionic equation to write because no reaction has actually occurred. Everything's just floating around next to each other. All right. Well, that's going to do it. Make sure you're practicing all of these and make sure that you get very good at recognizing the net ionic equations. And don't forget these 3 rules. These are going to be the ones that are tested on the most. All right. Have a good day, guys. Bye-bye.